Test, test, test. Okay, hello everybody, and welcome to the Tuesday 118 meeting of Chem 220. So, my video is not showing up here. There we go. So again, welcome to Chem 220, the January 18th version. So today we're going to have an extensive conversation about hydrocarbons. The molecules that contain only carbon and hydrogen. So although we'll mention sulfur and nitrogen and other things as part of fuels, the molecules themselves that we're going to be discussing are going to be the hydrocarbons. So with that, let me go ahead and share my screen with you and bring up our notepad. Just a little bit. Let me get on my okay. So, no, let me keep going. That's just the cover page. All right. So the hydrocarbons. So I have 4 different hydrocarbons on this first page. The simplest one we've already discussed before, methane, carbon and 4 hydrogens. So we see that carbon always likes to have 4 bonds to it, not necessarily 4 things. So methane obviously does have 4 hydrogens, but other forms of carbon may only have 3 different atoms. Therefore, there must be 1 double bond. We saw how carbon dioxide, CO2, has only 2 atoms attached to the central carbon. And therefore, that's why we had 2 double bonds. All right. So as a background, many times we use this term natural gas. You've heard that expression many times. So most of natural gas is methane, with some ethane and propane mixed in, but the predominant hydrocarbon in natural gas is methane. And the predominant use for that is to generate electricity. So just like when we discussed coal. So if you put coal into a boiler, you boil the water turns into steam, the steam goes into a turbine, which then makes electricity. It's the same thing here. So we're just swapping out the coal for methane. Now, what advantages does that have for a coal plant? Well, first off, if you swap your boilers over to natural gas, you've instantly eliminated one problem, and that is ash. So when you burn methane, you don't get any ash. Now, there are still problems, obviously, because when you burn methane, just like when you burned carbon, even in a complete combustion, even if it went perfect, you would make CO2 and water, and then obviously heat that you're using to make the steam. Now, the CO2 is the issue there because it's a greenhouse gas. Now, the other issue with using methane as a fuel for these giant electrical boilers is that oftentimes it's difficult to trap all the methane. You get leaks. And in the drilling and fracturing of rock to open up reservoirs of methane, you get leaks. And the methane goes up into the air. And just like CO2, methane is another greenhouse gas. Matter of fact, it's even more potent than is CO2. However, there's vastly less methane than CO2 in our atmosphere. And that's certainly leading to difficulties with climate change. Now, I remember our last discussion when we were talking about burning coal. There were a lot of chats that kind of went a little political. I love the enthusiasm. I think that's great. However, you know, sometimes our enthusiasm can get the better of us, and we get a little heated. So I would prefer any chats to be very specific and not borderline political discussions. Obviously, global climate change is a politically hotly charged topic. There are some people in our society who don't think that that really is happening. But I don't want to also ruffle any feathers here. All right, so let's get off the political stuff. So keep the chats civil and kind to each other. Now, let's get on to other uses of methane. So natural gas, you know, you probably in your neighborhood or maybe your mom and dad's house, they have gas stoves, and you might be cooking your food with a gas stove, or you might be heating your water heater with natural gas. So you see that's very powerful. We can in a lot of ways. Getting some. Please mute yourself if you're on. I'm getting some chatter. Sometimes you don't realize you're not muted. All right. So again, the second hydrocarbon now. Let's go down from methane. So the next most complicated hydrocarbon is ethane, C2H6. Now, notice what I've done over here to the right. Here's another way to write C2H6, CH3, CH3. So there's a little bit more information here. Now, obviously, the carbon is not bonded to hydrogen, hydrogen, hydrogen. Hydrogen can only make one bond. So anytime you see something like this, you know that that hydrocarbon that my arrow is on has three hydrogens on it. These three, one going up, one going to the west, one going to the south. And then this bond is the bond connection between that carbon and that carbon. I know it looks like that bond is hooked up to this hydrogen, but it's just an artifact of how we write things. These two carbons are hooked together, and each carbon has three hydrogens attached. Now, notice what I have up here, this little line, straight line. This is called the line notation for organic chemistry. And how you read this is anytime a line just terminates into space, that is a carbon atom there. And that is a carbon atom. In the line notation, we do not show the hydrogens unless, now this will be for later, if we start talking about hydrogens that are on oxygen or sulfur or nitrogen or phosphorus, then you explicitly draw the hydrogens on those, what we call heteroatoms. A heteroatom just means it's not a carbon. That's all hetero means. All right, so we have one, two, three different ways to make ethane. All right, keep going. Let's go to the next most complicated hydrocarbon, and that is propane, C3H8. So here is the CH3, CH2, CH3. This is the formula for propane. And here's the line notation for propane. So here again, we're terminating. So we know that that terminator is a carbon atom. Carbon wants 4 bonds. Right now, that arrow is pointing to a carbon atom that has shown only 1 bond. It needs 3 more. And those other 3, since they're not shown, must be hydrogens. Let's go to this little apex here. Now here we have 2 lines that are coming together. That apex, again, it's understood to be a carbon atom. And in this case, that carbon atom is connected to 2 bonds, a bond to this carbon atom and another bond to this carbon atom. So that carbon atom then needs 2 more bonds. And those 2 more bonds, obviously, since they're not shown, must be hydrogens. So that's this central CH2. Then lastly, the CH3 is just like the one on the other side. So there's the formula of propane. Now, what do we use propane for? Well, a few things broadly in society. Maybe you have a grill on your back deck and you have a cylinder there, a propane cylinder that you use for your propane grill. There are forklifts inside warehouses that use propane gas to use. There are buses that use propane to fuel their engines. And again, the nice thing about propane, very clean. You don't get very much soot, these hydrocarbon byproducts, like you do if you have a diesel bus. We'll talk about diesel later. That's for later on today. Now, this 4th one, D, butane. Notice I have an N. The N before the butane means normal. I don't know where that expression comes from, to be honest with you. Carbons are not normal or abnormal. I don't know where this came from. But whenever you see N, that stands for normal. And that means that those carbon atoms are all in a straight line. They're all contiguous. Look here, CH3, CH2, CH2, CH3. So that's butane, normal butane. And let's look at the line notation. CH3, CH2, CH2, CH3. So here's the line notation for N-butane. Now, there's another hydrocarbon with this exact same chemical formula, C4H10. This formula for butane could also apply to isobutane. Now, what is isobutane? Isobutane is an isomer. We're going to talk about this in a minute. It's a constitutional isomer of N-butane, okay? Now, what is isobutane? CH3. Now, look at this bond here right in the middle of the Y. So there's a carbon atom, and it has 3 bonds to it, doesn't it? How many more does that carbon need? Only 1, right? Only 1. So what's missing on that middle one is a single hydrogen, I'm sorry. So that's a CH3, that's a CH3, that's a CH3, and that's a CH. So here it is, written out. CH3, that's this one. Here's the middle carbon with an H, a CH3, and a CH3, a CH3, and a CH3. So this is called isobutane. Now, in organic chemistry, we actually have several different nomenclatures, methodologies. So isobutane is what we call a common name, But there's a more formulaic way to name organic compounds, and that is IUPAC, the International Union of Pure and Applied Chemistry. Now, I will never ask you on a test to name anything. I will always give you the structure and the name next to it. For this kind of a class, it's just not worth the effort to expend all of our valuable neurons on minutia. And I consider this basic nomenclature to be minutia. So you'll have the name and you'll have the structure right next to the name. So that'll take a little bit of the stress out of things. But if I were, just for, I know some of you are curious, if I wanted to name this in the IUPAC nomenclature, how would I do that? Well, the way you do that is you find the longest contiguous chain. What contiguous means, the longest chain without branching. 1, 2, 3, there's a contiguous chain. 1, 2, 3, there's a contiguous chain. 1, 2, 3, there's a contiguous. So there's 3 different ways, but that's the longest chain that I can draw without a branch. So 3 carbons is actually propane, right? So the way to name this is 2. Here's the carbon. Let's number them. Carbon number 1, carbon number 2, carbon number 3. And on the carbon number 2, there is this methane group. So in the IUPAC nomenclature, this is 2-methyl propane. That's synonymous with isobutane. They mean exactly the same thing, and they have exactly the same chemical formula. But again, do not fret, do not worry, do not get everything yourself into a tizzy. You don't have to name anything, so don't worry about that. Now, butane, N-butane, and isobutane are known as constitutional isomers. Now, that name you do have to know. Maybe you should get a part of your notebook that is vocabulary. And this is one of those words that I think you have to know. Constitutional isomers. This kind of isomerism is a connectivity where you have the same formula, but the connections are different. That's known as a constitutional isomer. Later on, we're going to talk about configurational isomers and stereoisomers. Those are other kinds of isomers. But this is a constitutional isomer. Now, all 4 of these are gases at standard temperature and pressure. All right. So now, can we liquefy methane? Yes. How do you do it? You got to get really cold and go under pressure. Ethane, you got to get very cold and under pressure. Now, propane is much easier to liquefy, right? It's in that metal container. It's in that big metal cylinder. And that metal cylinder is pretty thick, but it's not real thick. So the amount of pressure inside that liquid propane tank that you get from the hardware store, the grocery store, that pressure is fairly modest. And if the temperature ever gets really cold, sometimes that pressure goes way down and it's hard to get that gas out of the cylinder so that you can cook your hamburgers. All right. Now, N-butane and isobutane, these 2 isomers of butane, you probably have seen cigarette lighters or fireplace lighters. And if you look at a Flick Your Bic lighter, sometimes they have that little window that you could see. And if you look in there, there's a liquid. So inside that plastic container, under a slight pressure, again, it's very modest. So to make gaseous butane into a liquid, you just have to put it under modest pressure. And that's why when you push the valve, you hear the little, now don't put it up to your face because you'll light your hair on fire, but you'll hear a little hiss if you don't spark it. All right, so let us continue with our journey of the hydrocarbons. I have to get to my iPad again. All right. Continuing on. So from C4, we get to C5, pentane. Now those first 4, those names are probably not familiar to you, are they? Methane, ethane, propane, butane. Those are not names that you are really familiar with. But now the rest of these, you probably are familiar with. Penta, pentane, 5. A pentagon has 5 sides, right? Pentane is C5 hydrocarbon. And again, There's a lot of isomers now. You're starting to get into the realm where the different ways that you can attach 5 carbons goes way up. Then we have hexane. A hexagon has 6 sides, so 6 carbons is hexane. This maybe you're not familiar with. A 7-sided figure is a heptagon. So 7 carbons is heptane. You know what an octagon is, right? That's a stop sign. So octane has 8 carbons. Nonane kind of like heptane. Those are 2 odd kind of shapes that we don't really interact with very much. But a 9-sided mathematical figure in geometry is called a nonagon. So 9 carbons is nonane, okay? And then lastly, deca for 10, decane. Right, so now there's many more. We just keep going. But again, you do not have to know the names. You do not have to know the structures. I will give them all to you. So where do we get all of these hydrocarbons? Where do they come from? Now, can we synthesize them? Yes, certainly we can. We can make them. But the vast majority of these hydrocarbons comes from the distillation of petroleum. And you know what petroleum is, barrels of oil. The Russians are planning on throttling back how much petroleum oil that they put out onto the market. And that's going to raise prices and, supply and demand. Saudi Arabia has vast amounts of oil. Venezuela has vast amounts of oil. So all of these countries are exporting. And probably what you may not realize is that in the list of countries that produce petroleum, the United States is number 3. We're the 3rd most producing oil country in the world. All right. So again, that's all of an aside, common knowledge. Am I going to ask you on a test who are the top 3? No, I will not. Okay. Your test will be basically from the homeworks and then what I call my study guide. That you've already seen week 1 study guide, and there'll be one every single week. These are the things I should know. These are the things I should know. All right. Now let's look at this little column here. This is what we call a fractionating column. So the crude oil, the big barrels of oil come in here, or tankers of oil. They come into this heater. And then this hot oil goes down into a column. Now, these are bubbles. These are little caps. So this is called a bubble plate distillation column. So the vapor goes up and it condenses, and then the vapors come around this little thing. It's called a weir. This is called a weir, by the way. So every stage gets flooded. This will be flooded. This is flooded. This gets flooded. So this is when this column is going, this is a layer of liquid, and hot gases are going up through the liquid. Then that's a purification step. Gas to liquid, liquid to gas. Then this then goes around the weir, goes up to the next bubble. Then every subsequent level of the column enriches the lower boiling compound and makes the bottoms the high boiling compounds. So in the end, what do we get? So at the very bottom of the column, way at the bottom, things that boil above 350 degrees. This is basically, oil that you use in your car for slippery, the oil that you put in your engine. Now, below that, there's even a fraction that's above 340, and that's just basically a solid at room temperature. And those column bottoms we let harden, and after they harden, we crack them up, and we mix them with asphalt and put them out on the road for repairing roads and making asphalt roads. Now, going up, this layer, this higher boiling, is what we call bunker fuel, which they use in big giant ships, okay? And for some heating systems, not really so much for home heating. That's usually a little bit higher. Now, let's keep going up. What's the next highest, this 260 degrees C boiler? Well, this level is diesel oil. So I have an old diesel Mercedes, and my wife has a diesel tractor for our farm. And so and she has a big diesel truck for when she takes her horses to shows. So diesel fuel, has to be used in diesel engine. Very, very high compression. We'll talk about that when we talk about diesel fuel. Now, it turns out the kind of fuel that I use in my diesel car is actually not diesel fuel, but a different kind of fuel that I call biodiesel. It's a diesel substitute that I make here at my house from old cooking oil from a restaurant nearby. Going up, we get jet fuel, kerosene, all right? So this is used in jet engines, and we're starting to see a changeover where some aviation companies are starting to use biofuels in their jet engines to make them a little bit more green. Obviously, the aviation industry is a very polluting industry. They crank out a lot of CO2 per year because obviously a jet engine uses a lot of fuel. You ever see the tanks on a big commercial jet engine? All right, let's keep going up. So now we're going to the lighter ones. We're going up to this stage, 100 degrees C. Remember, this is degrees Celsius, so 212 Fahrenheit. Naphtha, it's used for chemical making, but it's also used for a thing that we call white gas. Maybe you have a Coleman camping stove. A lot of that is white gas, okay? Continuing up even lighter, we get 30 degrees Celsius, gasoline that we're all familiar with. And then there's all these lighter compounds, refinery gases, and some methane, ethane, propane. Some of this gets turned into fuel to heat the boiler, which we hope. But some refineries, they produce too much gas. So what they end up doing is they flare the excess gas. Some mining operations, some fracking operations that produce more gas that they can consume, they also flare their light gases. Flaring is a very environmentally damaging process by the petroleum industry. Again, it's needless, it's wasted heat. You're throwing a lot of CO2 up in the air. So that's that. All right, so you see up here the gases, then we have the liquids, and then they go down to the solids. So both the boiling points and the viscosity, how thick the stuff is, goes down. And I can tell you, diesel fuel is quite thick. It's very oily, which makes it kind of safe because it's much less prone to blowing up like gasoline, but it has other issues. Okay, so continuing on. Now, I want to get back to this notion of line notation. Line notation. Right now, every molecule that I've talked about, they're called the saturated hydrocarbons. What does that word mean? Let's look at that word for a second. Saturated hydrocarbons. Saturated hydrocarbons contain only single bonds, no double bonds. So if you look at all those 10 compounds that we just drew, methane all the way through decane, all of those compounds are known as the saturated hydrocarbons. Now, if you ever do have a double bond, well, I'll go ahead and give you one just as an example. 2 carbons that have a double bond. And again, carbon always has 4 bonds. But in this case, both of these carbons are only attached to 3 things. So this carbon on the left is attached to 2 hydrogens and a carbon. The carbon on the right is attached to 2 hydrogens and a carbon, okay? And in between is my double bond. So in the beginning, I said that 2 carbons was ethane, A-N-E. Now, if you ever have 1 or more double bonds, the ending changes to ENE. ENE, ethene. And this is an unsaturated hydrocarbon. All right. And we can even go further. I might as well go ahead and give you the last kind of carbon. And that is when we have a carbon that's only attached to 2 other atoms. And that therefore that means that carbon has either 2 double bonds or a triple bond attached to it. Now, one of those we saw was CO2, right? So that carbon is attached to 2 atoms and 2 double bonds. Now, another carbon, let's do the triple bond version of ethane. So each one of these carbons is also attached to only 2 things. So a single bond to that hydrogen to the left, that way, and a triple bond to the right. You got a double bond here and a double bond here. Again, look, carbon always has 4 bonds. But these now, this is called ethyne. 2 carbons. Oops, sorry, my eraser. YNE. So that's how you can tell. If the ending is an ANE, you always have single bonds. 2 double bond, ENE, triple bond, YNE. Sorry, let me turn up my speaker. I think somebody just said something. My speaker's
Yes, sir. I've got a question.
Okay, now I can hear you.
Okay.
But sorry, my volume was off.
You're fine. So the saturated hydrocarbons only have single bonds.
Correct.
Unsaturated have at least 1 double bond or at least 2 double bonds.
1 or more.
Okay, 1 or more.
Or a triple bond. That's also unsaturated.
Okay, and so then the triple
1 or
bond,
more triple bonds are their YNEs. Now, sometimes you get double bonds and triple bonds and single bonds all mixed up together. They're all in the same molecule,
yes,
right?
sir.
Now, if you ever get that situation, you always defer to the YNE. Now, some molecules are called, like say I have an ene, an alkene, and an alkyne in a particular configuration. Gets more complicated. We call those eneines. Don't worry about it. Again, I will always give you the name and the structure right next to each other. But there's a whole class of very important chemotherapy agents that are called eneines, and they're going to be even more important in the near future. But that kind of gives you that idea. Okay, so again, some definitions that I think you should put on your vocabulary cards. I think that you should know what a saturated hydrocarbon is. If I asked you to explain, now again, that's a simple 1 sentence. You know, a hydrocarbon that has only single bonds, okay? If I ask you about alkenes, you should tell me 1 or more double bonds. Alkynes, 1 or more triple bonds. Now, these are the 3 dominant forms of carbon that we're going to discuss in this class. I will show you the final one right here. This is a very unique kind of molecule called an aromatic carbon. So we have saturated carbons, we have alkene carbons, we have alkyne carbons. The 4th and final kind of carbon that we're going to discuss in this class are called the aromatic carbons. Let me show you the most famous one of all. That's called benzene. Now, I know it looks like an alkene, doesn't it? It looks like 3 alkenes in a ring. But those carbons are not like alkenes. We're going to discover later on, they do none of the reactions like a normal alkene undergoes. There's a certain stability in this molecule. And when we get to the aromatics, we'll show you where the stability comes from. But an aromatic is when you have alternating double and single bonds in a ring, all of those carbons in the plane, all in the plane of the board. And again, remember what those carbons mean. So the formula for benzene is C6H6. Is that right? Let's see. So this carbon way over here is a carbon that has 1 bond, 2 bonds, 3 bonds. The only thing it's missing is a hydrogen right there. So there's a hydrogen right off that carbon. Same thing over here. This top carbon atom. How many bonds are connected to that carbon atom? There are 3. 1, 2, 3 bonds connected to that apex carbon atom. So it only needs 1 more. And what is not shown is a hydrogen. You can do that for the others. So that's benzene. I'll write the name for you. Very important. I know it ends in ENE, but it's not an alkene. Benzene is it used to be a commercial solvent, and we used to use it all the time when I was an undergraduate in the laboratory, to clean glassware. Very common solvent for reactions. Unfortunately, later on, it was discovered that benzene is carcinogenic. So hopefully I dodged the bullet, and I haven't touched benzene in probably 15, 20 years. So maybe I got away with it. But a lot of my colleagues ended up getting cancer because they were exposed to not just benzene, but other aromatic hydrocarbons. All right. Now I want to pause for a moment because there's several people who emailed me about the homework that's due tonight. So before I get too far and forget about it, I'm gonna stop this pause and I'm gonna pull up the homework real quick. All right, share screen. Oh, another thing too, before I forget, let me move that down. Come over here. I want to show you something also in our Moodle page real quick. Let me bring up the Moodle page real fast here. Share screen. Let's see here. I get to my. Can you see the Moodle page right here? Yeah, hopefully. All right. Now, if you go down to these lectures, I had inadvertently selected private. I changed that this morning to be public. So you can get into those lectures and view them. If you had trouble earlier, you should be able to get into those lectures without any trouble. The other thing is this practice homework that's due this evening. All the homeworks will always be due at 10 p.m. Okay, always 10 p.m. I always set that as the date, depending upon what the date is. Now, this practice homework, if you've tried it, you would have noticed that, as you select your answers, it wasn't giving you any feedback. It wasn't saying, oh, this is correct, this one's wrong, because you get 3 tries. Every homework, you'll have 3 attempts to get it right. But, if you don't know which ones you got wrong, that set up the dilemma. So let's say you got 8 out of 10 on the homework. Well, which ones did I get wrong? I don't know. So what could happen there is you may change one of your right answers to be a wrong answer. Your grade would go down. So we don't want that. So I phoned a colleague this morning to figure out where to do those toggles. And so she showed me where to go. And so now when you hit that submit button, you get 3 submissions. When you hit the submit button, it should come up like, this is right, this is not right, this is right, this is not right, so that you can go back to that problem and then give that another try, okay? Obviously, this first homework is nothing fancy, so you don't have to worry about that. It's just basically getting you used to the homework tool. Some of you have used this before, so it's not a big deal for you, but for some of you, it's a little bit more of a problem. Now, with these homeworks, sometimes there's a dilemma about, do I use capital letters? Do I use a mixture of capital and lower? Most of the time, my default is to say that that doesn't matter. So you could put your answer in all capitals. You could capitalize the first one and not capitalize the rest. You could put it in all lowercase. So most of the time, it's not case sensitive. If a question ever is case sensitive, then I will ask you to be careful with how you input your answer. And also spelling is important. So if you write carbon, C-A-B-O-N, then that's not correct. It's going to mark you wrong. So sometimes I know you meant carbon, but you forgot the R and you put in carbon. Maybe if you're from Boston, that would work, but not around here. So unfortunately, the program, I can't possibly anticipate every possible spelling mistake. So I would ask you, if there's ever a word that you have to input, be careful of spelling. Maybe cut and paste it into a spell checker or something to see if you got that correct. All right. Another area where the homework can be a little problematic is with numeric answers. So again, I help you out here. Now, a lot of times I try to make answers work out to be whole numbers. So there's no decimal places. But sometimes that's impossible. So instead of using significant figures, I will tell you in the problem, on a numeric problem, the answer to 1 decimal place, 10.3, okay? Or the answer to 2 decimal places, 10.29, okay? So again, but I try to avoid any complicated where a number will screw you up. There's not that many numeric, we don't do that many calculations in this class. So you don't have to really worry about doing meticulous math and significant figures, not for this course. All right, so that's the homework. Now, the next thing I want to do before we get too far into this, I want to do a practice Kahoot problem. So if you have, maybe, I don't know hopefully you put it on your telephone or maybe your laptop or your iPad, whatever it might be. So I'll give you a minute to bring up your Kahoot app. If you don't have the Kahoot app, you can just go to kahoot.com and it will bring up the Kahoot program for you. So you don't have to worry about that too much. But I'm going to stop my share now and I'm going to bring up Kahoot. Let's go. Kahoot. Let's see. Where's Kahoot? I wonder if I closed it by mistake. Oh, nope, there it is. Okay, yeah, okay, good. All right, let me go back and share my screen with you. Let's go here. There's my Zoom. There it is. Patience, patience. We'll get there. So many different toggling around here. Share screen, share screen, share, and Kahoot. Might have to minimize this for a second. Get that out of the way. Can't see everything. Too many windows open. Now I'll try to make this window big. Does everybody, can everybody see this Kahoot page? Yeah, okay, good. Now, the way this is gonna work is I am going to play this game. I know there's a lot of play in this. So I'm gonna go ahead and play this Kahoot for you now. Don't worry about it. This is not gonna count towards your grade. No stress, everybody tranquilo, please. But what's gonna happen is when I hit play, a number is going to come up. And you are gonna have to input that number when you play the game. So if I press play right now, and I say start, takes a minute. I'm gonna go classic mode, just player versus player. It's gonna try to make it competitive with everybody. Don't try to compete against other people. This is not about that. So classic mode, get ready to join. Okay, so here's the number, 8989673. So if you would go to your Kahoot app and put in 8989673, okay? And then I'm just gonna let this go out because unfortunately this program slows down with more people. So if you find yourself where you're waiting to sign in, don't worry about it. It'll eventually let you in. And I'm not gonna start until I see most people have signed into the Kahoot game. And again, you're gonna laugh at this quiz. It's a stupid quiz. So don't fret that you're going to get a low grade because this grade doesn't even count.
Hey, in the future, do you want us to use our name or the ID Kahoot number? that you
Usually the
wanted us to
ID.
use in that email?
You see the ID numbers instead of your name. I would use the ID number because otherwise, you know what? Because everybody sees your name, and you don't want people. I don't know. I'm kind of shy. It's not that I care about what people see that I get, my grades, but it's kind of like the laundry. You know, you go to laundromat and you put your laundry in the washing machine, and I can't stand when somebody moves my laundry to the dryer. You know, I'm not ashamed of my underwear. They're fine. They're just like everybody else's, but it's just kind of private to me. So I don't want anybody else knowing my stuff. So if you would use your Kahoot name, you know, it ends with PB. All the numbers should end PB. That would be great. Whatever your number was in that chart, the last thing should be PB. It looks like most people have logged in. We'll get started here in just about 3 minutes. Again, like I say, if you do have that Kahoot number, that's way preferable. Do not want you to show your identity to anybody. Okay, so up to 150, we're getting there. Still people signing in. Okay. You know, sometimes even if a Kahoot has started and you come in the middle, it'll still let you jump in. Now, unfortunately, it doesn't let you jump back to old questions, unfortunately. once a question is passed, then you can't answer the old questions. But I think it does allow you to enter new questions. All right, so we are going to begin now. And again, don't worry if you happen to miss it, that's okay. This is just to get us used to using the Kahoot program. So let us go ahead and begin. And I'm going to start the quiz right now. Getting to know your teacher. 2, 1. Okay, here comes the quiz. What is your teacher's name? So you got to choose from these 4 different options. So Dr. Pauling, Dr. Einstein, Dr. Fauci, Dr. Brown. So you just choose one. Don't choose more than one, because you obviously only have one teacher in this particular Kahoot. This gives you a countdown. This tells you how much time is left for you to answer. Now, I adjust that. Typically, I will adjust that depending upon, oh, so somebody thought I was, who was that? Dr. Fauci? No, not Dr. Fauci. I do admire Dr. Fauci very much, but I'm not as smart as Dr. Fauci. Okay, so good. Most people got that right. And the way I use this is that if I see where I ask on a real Kahoot, if I see that a lot of people have gotten one wrong, then that tells me something. That tells me that I didn't teach that topic very well. And I will go back over that particular area to try to get you back. So you might see a Kahoot question a second time if a lot of people got it wrong the first time. Okay, continuing on. So here's the scoreboard. And these numbers, don't worry about it. It depends upon how fast you logged in and if you got it correct. But again, whoever this person is, you're at the top of the leaderboard, but don't worry about it. All right, question number 2. Dr. Brown teaches what? Analytical chemistry, physical chemistry, organic chemistry, or nuclear chemistry? Very famous picture here, by the way, while you're inputting your answers. This is Dr. Eschenmoser from the Swiss, the Antioch. B12, vitamin B12. And this is the structure, this heme portion. And you see the structure there. Okay, everybody got that right. I'm an organic chemist. All right, so let's see how everybody did there. Who's still in the lead? 650 PB, you're a fast one. You're fast on the kind of like Jeopardy, whoever dings in quickest. So it's not just who gets the right answer, it's who gets the quickest. But again, nobody's keeping score here. Third question. Where does your teacher come from? There's a hint. Look at the picture. I hope you know what that is. I'll give you a hint. That's the Brooklyn Bridge. These are the Twin Towers before those jerks knocked them down. Yes, I am from New York. Grew up on Long Island, small town. Well, I was born in a small village of Queens called Bayside, Queens. And then my family moved out to East Islip, Long Island, on the south shore of Long Island. All right, let's see how everybody did there. Ooh, wow, very good, 650. You're a fast one. All right, continuing on. Isabel, you should change your name because now everybody knows it's you. You should change your name to your number instead of your name. All right, continuing on. Let's keep moving forward here. What animals does your teacher have? Again, the picture will tell you. So is that a picture of a horse, a cat, a bunny, or a dog? Better not say dog. That kind of looks like my wife's horse too, by the way. She's got a paint. Correct. She has a horse. We used to have cats and we used to have dogs, but the last dog we had died a few years ago and the last cat died last year. But through our whole lives, we've had cats and dogs, and we've always had horses too, but the cats and dogs are now in animal heaven. Okay. Continuing on. Ooh, somebody took the lead. Continuing on. Fifth question. What's one hobby of Dr. Brown? Painting, golf, running, playing music. What's Mickey got in his hand? That's right. I enjoy golf. I'm not real great at it, but that's something I do. I do run on occasion. I don't like it. It's hurt. It hurts, but I try to do it just to keep my weight down. Painting, forget it. Playing music, I play music, but more I like to listen to podcasts more than music, though I will listen to music every once in a while. But the big hobby of mine that was in that picture of Mickey was playing golf. I'm not real great at it, but I do enjoy it. All right, continuing on. Sixth question. Where does Dr. Brown teach in the summers? Again, there's a map up there. Here's the Guadalquivir, Rio Guadalquivir. Here's Sevilla. Does everybody know where Seville is? Sevilla in Espanol. My office is right there. Que bueno. Yes, Spain. So I teach in Sevilla organic chemistry most of the time. Sometimes a chemistry business class, but mostly organic. I've been doing that for a while. I haven't done it since COVID because study abroad, obviously. COVID is not going on right now. It is unfortunate, but they've canceled me the last 2 years. So I don't know if I'll be back or not. Since I'm retired now, they may not ask me back, but I still have a lot of friends in Spain, and I'll definitely go back for at least pleasure. If you've never been to Seville, I would highly recommend it. It's one of the top places in the world that you should go visit. It is an absolutely beautiful city, wonderful people, tremendous food, a very easy place to get around. You know, it's not that big. It's not like going up to New York or out to LA. You know, you can walk most places. It's quite wonderful. All right. All right, so here we go, school board. Oh, getting up there. Okay, so let's go to our next question. 7 out of 8. What are some interesting facts about your teacher? Now notice that says select all that apply. So if you think there's more than one answer, you should select more than one answer. Did I go to BC? Did I get a PhD at NC State? Did I postdoc up in Pittsburgh at Carnegie Mellon? Do I have 2 daughters? I'll give you a hint. There's Megan and Kelly right next to that Brooklyn Bridge up in New York. That's very old, by the way. They're way, yeah.
We
Yeah.
can't select more than one answer. We can only
It won't
select
let you
one
select
answer.
more than one? Oh, okay. That might be a fault in my questions. I'll have to, but look, you see how they're all good. So hopefully no matter what one you chose, you would have gotten a right answer. But I think to get the full credit, you have to select all, because all of those are correct. In order to get them all right, you would have had to have select all of them. But I'll look into the Kahoot questioning for later, for real Kahoots, to make sure that that's not a problem down the road. That's why I'm doing this too. It's kind of a debugging for you, but also kind of a debugs for me. So right now I know that this type of a question where you have multiple selections could be an issue. So I don't know how this, I'll have to wait to see how it scored everybody, whether they gave you the points for just one answer or they gave you only the points if you selected all of them. I don't know. I guess I'll have to look at the tallies after we're done. Okay. I think no, we're not done. We still got one more to go. Sorry. Okay, continuing on. Let's go on to our last one. 3 in a row. 191 is back in the game. Oh, there you go. Getting some people skying. Okay, last one. Is chemistry relevant to your major? No, not really. Absolutely. I'll never have to use it. Just select one. This is not a multiple choice one. Just select one. My guess is everybody is in this course because you have to be, not because you chose this because you want to be. Maybe there are a few. I hope so. But I hope at the end you'll have at least some appreciation for what chemistry can do. And absolutely, this course is important to everybody. I don't even care if you're an English major. Chemistry is relevant to your field because English majors, you have to write, you have to read, all that is chemistry. You got to take everything is that's material, by the way. Everything is chemistry. That is of matter. Now, can chemistry explain love or hate or jealousy or racism? No, chemistry can't explain those. That's a realm that chemistry has no dominion over. But chemistry explains most other things that are part of our material world. All right. So who won? There you go. Yay, you get the gold star. Number 2. Well done. Number 3. All right, there you go. So I wish I could turn this off. I don't know how to turn this off. Everything in this game is about these podiums. Kind of a stupid program, but it is free. So I like that part of it. And so we don't have to worry too much about paying for anything. Again, nobody pays for anything. All right, so I'm going to stop the share again, get back to our main podium here. Now, we only have about 15 minutes left. So I want to open it up to a more general discussion about the course itself. I'm trying to remedy things along the way. Like I saw some problems with the Moodle site, and I saw some issues with the homework site. Now I've just identified a Kahoot problem. So hopefully as we go forward, any sort of technical issues are done with. Now, we will have one more Zoom class on Thursday, but it is my intention to have a class a week from today in Dabney. Again, please take that with a grain of salt, because if the physicians over there at NC State, they come back and tell me, look, you're taking too much of a risk and there's too many people. I've already had about 9 of you already tell me that you already contracted the COVID, and that's just the people who have told me. I don't know how many others of you have gotten it. I don't know how I've not gotten it, but fortunately, well, knock on wood, I haven't really gone out of my house a whole lot. Maybe that's part of it. I go to my granddaughter's volleyball matches. That's about it. And I always stay way far away from everybody. So I've been lucky. I hope you have too. But if you have gotten it, if you've been vaccinated and boosted, my thought is that you probably have very mild symptoms. That's not perfect. Even people who have been vaxxed and boosted can still get very sick, but that's the rare outcome. Most outcomes are usually pretty good. So you might feel bad. A friend of ours down the street, she had a sore throat and kind of bad headaches for a day or two, but she was vaxxed and boosted and got over it pretty quickly. And she's isolating herself now. All right, so that's it for the formal part of the class. Now, I sent you out an email yesterday, I mean this morning, that was part of the Zoom, that unfortunately I couldn't get on. I had some issues with my internet this morning. So I couldn't get on my computer this morning for office hours. So I'm moving my office hours, that 10 to 11:15 office hours, to tomorrow. So basically what I do is I'm going to throw out a Zoom meeting tomorrow morning, and I'm just going to be on my computer, and it's an open forum. I'll have my iPad. So if you want to ask me something, I can draw out structures or type stuff in. So you shouldn't have too much trouble asking me. Now, I don't know how you could input structure though. Yeah, that might be an issue. I guess you could use the chemistry drawing program. I hope most of you have played with that a little bit. Some of you, maybe not. We're gonna do a lot more chemistry drawing program on Thursday. So be prepared. I'm going to show you how to input more elaborate structures and how to do some more manipulation, three-dimensional manipulations. So with those. And then on Thursday, we'll have a normal office hour. So there'll be 2 Zoom meetings on Thursday. The office hour one from 10 to 11:15, and then our 11:45 to 1 p.m. course Zoom. So there'll be 2 ones there. Now, when it comes to next week, we're gonna, there's a different kind of program that is used with ClassTech. Panopto is a program that will capture my lecture. So I'll be Zooming while I'm Panoptoing. Okay, I know that sounds crazy, but there's be two pieces of software simultaneously going on. So the Panopto will allow me to capture anything I draw up on the board. If I bring in a demonstration on the tabletop, it will capture that. So it's basically like capturing the Zoom class, but it's just capturing it with Panopto. Okay. Now, but also I'll capture it by Zoom. So you could do both. I think Panopto is a little bit more powerful. So you're probably going to want to look at the Panopto rather than the Zoom. But it's up to you, whichever you like. But it will be simulcast. So just like you took a Kahoot today, you will be able to, like, say on next Tuesday, God forbid, I don't wish this upon anybody, but let's say Sunday night, you wake up in the middle of the night and you got a sore throat and a pounding headache, and Monday you go in, you get tested, sure enough, you got the COVID. Well, don't worry about it. Please, under no circumstance do you come to class on Tuesday. You isolate. This 5 days, no. You isolate yourself for 7 days. I talked to my doctor this morning. I had my physical this morning. You isolate for 7 days. And then when you're asymptomatic, asymptomatic, I don't know what the word is, asymptomatic, you come back, and then you can come back next week. But please, again, we could, given how many people we have in this class and how small this room is, how packed we are in there, you could get a lot of people sick really fast. So do not show up. Just get on your computer. I'll send you the Zoom link and just Zoom it, just like we've been doing. You don't have to worry about it. Now, if you can come, sure, I would love to see you. I see these little faces on the screen, and I can only see so many at a time. I got to keep flashing through here. It's 5 pages of students here. Good grief. Wow. Some little bambinos. Oh, that's so cute. That's nice. Haven't had little babies around. My grandkids are a little bit older now, so haven't had any little ones around, but I miss them. I see some puppies and kitties in there too. Wow, some of you guys are real animal lovers as well. All right, so there's about 5 minutes left. If you got any questions, you're free to ask them, or if you want to save it for office hours tomorrow, that's fine too. Whatever's comfortable. Everybody okay? you please
I
show
have
us
the
your notes?
notes
So the
here.
notes are the notes that were on my iPad there, my iPad. Those are going to be in the Zoom meeting. So yeah, so you have those, and you can look at them. You can pause it, fast forward, go back. So any notes that I put on my iPad, you have all of those notes once I stop. Now, today's Zoom, I will try to put up by tonight, but I tell you, I am sitting out here in the country. We're in horse country out here, and I have this little crappy DSL line that is really, really slow. So my uploads take 3 and 4 hours to put up a 1-hour lecture. So it definitely is going to be up by tomorrow morning. So you'll be able to see that. And it will be public. Everybody can look at it. But yeah, please feel free. I do have one last thing. Oh, before I forget, one last thing. Last lecture. If you would look at the lecture slides from last Thursday, there was a section where I talked about Bronsted acid-base chemistry. And I used acetic acid and sodium hydroxide as an example. And I said next to acetic acid, strong acid. I misspoke there. I should have said stronger acid, not strong acid. If you look at a table of acids and bases, the pKa table, you will notice that acetic acid is actually a weak acid. The pKa, if you remember from general chemistry, the pKa of acetic acid is about 4.5. And remember, you got to be lower than 1 to be considered a strong acid. So a pKa of 4.5, you're pretty strong, but you're still considered weak. But now that reaction went from a stronger acid to a weaker acid. So if you looked at the product of that acid-base chemistry, one of the products was water, H2O. That's the acid in the product side of that equation. The pKa of water is 16. And again, you probably don't remember about the relative strengths and weaknesses, but the bigger the pKa, the weaker the acid. So a pKa of 16 compared to a pKa of 4.5 is very, very, very weak. Water is so weak compared to acetic acid, extraordinarily weak. And remember what the definition of P means. Negative log of that thing minus the log. So I know you may think that the difference between 16 and 4 is only 12. It's not 12. It's 1 times 10 to the 12th power. That's how much weaker water is compared to acetic acid. And that's why that reaction is very extensive. That's why it goes all the way to product. All right. So just a little correction there. If you would correct that in your notes, I will also correct it on my iPad. So where it said strong acid, I'm just going to say stronger acid. And then next to water, I'll make weaker acid. Okay. All right. I guess that's it. I've gotten to my time now. We got time for one more if somebody's got another question.
Will you send an email about the Zoom link for office hours tomorrow, what the Zoom link is?
Oh yeah, absolutely. Oh, for sure, for sure. Probably tomorrow morning I'll do that. I'll probably like 8 o'clock tomorrow morning. I'll send that out. Maybe I'll send it out tonight. If I think about it, I'll send it out tonight. But definitely no later than 8 a.m. tomorrow for a 10 a.m. office hour. Okay. And again, there's no agenda for office hours. Here's one thing though, please, with office hours. There's going to be, it's open office hours. So everybody in the class can see you and hear you. So if it's chemistry stuff, that's fine. But if it's any sort of personal things, email me and we'll set up a private Zoom call so that we can discuss those kinds of issues. Okay. Please don't forget that homework that's due tonight. I know it doesn't count for anything, but I would still like you to try it, to kind of debug it, because I'm going to learn from what you put in how to make better homeworks going forward. And then hopefully you will know better how to input answers to the homeworks. Okay. All right. So everybody have a good Tuesday. And I will see you, hopefully some of you tomorrow in office hours. And hopefully I'll see everybody Thursday in office hours and or class. Bye-bye.